Good morning to everyone. Good morning, Salwa. Good evening, Salwa. Good evening to everyone. Today we discuss about your topic partial differential equations. First, my name is Dr. C. Vasanthi, Assistant Professor, Department of Mathematics from CPA College, Bodinayakanur. First, we have to discuss about formation of partial differential equation. It is defined as an equation involving two or more independent variables like x and y. And a dependent variable like u, and it is partial derivatives. Partial differential equation can be formed either by elimination of arbitrary constants or by the elimination of arbitrary functions from the relations involving three or more variables. The first one is general form. The general form of a first order partial differential equation is f of x comma y comma z dou z by dou x comma dou z by dou y equal to, it can be written as equal to f of x comma y comma z comma p comma q equal to 0, where x and y are two independent variables and z is the dependent variable of x and y. Therefore p equal to dou z by dou x and q equal to dou z by dou y. Next we have to see differential integrals of particular partial differential equations. There is a four form. The first form is complete integral solution. The second form is particular solutions. The third is singular solution. The final one is the general solution. First we have to discuss about the singular solution. The singular solution is nothing but no arbitrary constant and is not obtained as a particular integral form of the complete integral. So equation is pi of x comma y comma z comma a comma b equal to 0. Then we get dou by dou a equal to 0 and then dou by dou b equal to 0. The complete solution is let f of x comma y comma z dou z by dou x comma dou z by dou y equal to f of x comma y comma z comma p comma q equal to 0 with the partial differential equations. The complete integral of equations one is given by pi of x comma y comma z comma a comma b equal to 0, and we are two arbitrary constants. Particular solution is a complete integral is called a particular solutions. Next we have to find general solution of the equation, differential equations. The general solution of the equations, variables, given variables together with an arbitrary function of these variables is a general solution. Then the equation of partial differential equation is given by pi of x comma y comma z comma a comma b equal to 0. Assume an arbitrary relation of the form b equal to f of a. So our earlier equations is become pi of x comma y comma z comma f of a equal to 0. Now differentiating to with respect to a, and thus we get dou by dou a plus dou by dou b f dash of a equal to 0. This is the equation 4. As the eliminator of 3 and 4, we get the general solutions. Next we have to find the types of the PDE. PDE means partial differential equation. The first type is the partial differential equation of the form f of p comma q equal to 0 as solution z equal to ax plus by plus c and f of a comma b equal to 0. The type 2, the partial differential equations of the form z equal to ax plus by plus f of a comma b is called the Charles form of PDE. And the type 3, if the partial differential equation is given by f of a z comma p comma q equal to 0, then assume that z equal to pi of x plus ay, u equal to x plus ay, and z equal to pi of u. Then we get p equal to dou z by dou x. It will be written as dou z by dou u into dou u by dou x equal to dou z by dou u. Differentiating with respect to the x, we get 1, that implies dou z by dou u. So similarly we get q equal to dou z by dou y equal to dou z by dou u into dou u by dou y equal to dou z by dou u. So differentiating with respect to y term, therefore ay is written ba equal to a into dou z by dz by du. Type 4 partial differential equation of the given form can be solved by assuming f of x comma p equal to g of y comma q equal to a. F of x comma p equal to a, that implies pi of x comma a, g of y comma q equal to a, that implies q equal to psi of y comma a. It will be depending upon the two functions. Therefore d is equal to dou z by dou x into dx plus dou z by dou y into dy. Therefore d is equal to pi of x comma a equal to dx plus pi of y comma a equal to dy. Next we have to see the examples of partial differential equation in the basic form. The first form is f of a comma b form, f of p comma q the form. So solve the PDE, p square minus q equal to 1. and find the complete and a singular solution. So the complete solution of the equation is given by z equal to ax plus by plus c with a squared minus b equal to 1, 30 plus b equal to a squared minus 1. Therefore z equal to ax plus a squared minus 1 into y plus c. Differentiating with respect to a and c, we get dou z by dou a equal to x plus 2a by dou z plus. So dou z equal to 1, which is not impossible. So we cannot get the singular solution. So that's equations have no singular solutions. The second problem is pq equal to xy or dou z by dou x into dou z by dou y equal to xy. Solution becomes b by x equal to y by q. Now we take a dz equal to p dx plus q dy, that is plus a into x into dx plus y by a into dy. Integrating on both sides, a into x squared by 2 plus y squared divided by 2a plus b. So thank you to any questions. Thank you for all. Good morning to everyone. My name is Dr. C. Vasanthi, Assistant Professor, Department of Mathematics. Today we discuss about the real analysis topic. The real analysis is we have to see the real analysis topic.